Hello students. So today we shall start a new chapter, that is structures in C++, right? So now what is a structure? Now structure is a collection of one or more values of different data types. So it is a collection of data values, but they are of different data types. So being able to manipulate several values of different data types in a single variable name, it makes the program easier to write and maintain. So now using the structure, you are able to collect different values of different data types under a single variable name or under a same name. So you are able to create programs related with the real world problems. All right, so you're able to create real world programs based on the real world, so solutions like that, and you are able to write down and maintain it. Now the structure is similar to an array in it, and at the same time there's a difference. So what is the difference between the structure and an array? Now structure is a group of variables of different data types under a single name. So you have different groups of different variables of different data types under a single name. In the case of an array, you have groups of variables of same data type under a single name, right? So under an array name, all the different variables are created, but they are all of the same data type. But here in the structure, you will have different variables of different variable names, all right, and they are all of different data types. So now, example, if you have to use array, we can have array of book details as, suppose like here. uh, so this is the array name book underscore author, right? So this array is a character array, right? Or it is string variable. So here you can see that the data type is character, and you have the array name book author. So this will create a group of variable so this will create a group of variables which will contain the name of the author, which the index size is 20, right? So you can see that in the case of suppose like book price, so the array here is of integer type. So now this book price, the index size is 5, so this will create the price of uh, say like 5 books, right? So this will create 5 array elements or 5 variables to store the price of 5 books, like that, right? So book title is also a character array which will store the which will create a group of array elements of the same type, right, which will contain the book title. So you can see that in an array we can have a single array name, and they are all of the same type. So here, even though you will have 5 different book price, yet they are all referred by this array name, and they are all of the same type. But now if we have to create say like a program based on the book, so we cannot merge this all together. So we cannot group all this information under one single name book using array, right? Now we can merge all these book details using structure. So structure, it can be defined as, so here struct book, and within the opening and closing curly braces, you can see that here I have written down these variables, right? So character title, int price, character author. So since all of these are related with the details of the book, so by using a structure, all right, and this tag called as book, so this tells that these members or these variables belongs to the book tag. All right, so you can see that this the execution of this will be same, because here you can see that when we use this bracket, the square bracket, that refers to as an array. So you can see that we are using an array inside the structure. So, and here this array is used to collect the details about the title, the price, and the author, but they are all used the same array elements of the same type, right? But yet they all are related because they are all related to the book. So using the struct, we can relate all this, we can merge all this information, collect all this information, and form one record for the book. All right, so that way we can create a real life program on that. So that is the main difference between a structure and an array, right? So you can see that now in a structure the elements are called as members. So here just like these array elements, right here, these are the array, this is the array name, so this will create the array elements. So this, in this case, these elements we call them as members. So the structure is defined by a structure name called structure tag. So how do you define a structure? The structure here, it is defined by this name, structure name, which is called as a structure tag. Now this structure tag is optional whether you want to write down the structure tag or not, but it is always a good programming practice to write down the structure tag, because by the structure tag you can see that the variable names or the members are also the member names are also declared in the same way, like EMB, because here the structure tag is employee, right? Now unlike array names, that is a reference array as variables, right? So in an array name, so this array name, it is referenced as a variable. This is actually a variable, but here in the case of a structure tag, in the case of this structure tag, this is not a variable name, but this is a label, right? So this is a label. So now this structure tag is actually a user defined data type. All right, so like array is also user defined data type, so here this structure tag is also user defined data type, and no memory will be reserved for these structure members until a structure variable is declared. So here you can see that a structure variable is declared in as emb1 emb2, that is a structure also declaration definition also ends with a semicolon. So this is a structure variable, that is emb1 and emb2. All right, so here these variables that is under the structure braces, they are called as members. These members belong to the structure variables, that is emb1 or emb2. That means the detailed information about emb1 and emb2 are these members. All right, so we can you can see that the structure tag, based on the structure tag, the variable names, the members are also associated. All right, so until and unless these variables, these structure variables are declared, no memory space will be allocated for these members, right? So we cannot use these members on its own like that. So these are actually the arrays, and this will create the array elements. So you can see that in a structure you have different variables of different data types, right? Different variables of different data types, and they are all referred by this structure tag employee, right? So, and then the memory space will be allocated only when you declare the structure variables, that is emb1 and emb2. So these are also user defined variable names. So the rules that are associated with while declaring a variable is also associated with a structure. All right, now how do you initialize a structure? So initializing a structure member can be done in two ways. First, we can initialize when declaring a structure, that is within the structure itself, the structure definition, the braces, opening and closing braces, within the structure body. All right, or initialization can be done within the body of the program. That means not in the structure definition but outside of the structure definition, right? So the first one is initialize the members when declaring a structure. So here you can see that the same example, all right, except that here you can see that after the structure variable, the values are assigned to the structure variable within the structure definition itself. All right, so here after this the semicolon will end here. All right, so now the so here you can see that this is a structure variable, and using the assignment operator within the curly braces, these are the values that are assigned to the structure variable. So when the structure variable is declared, then memory space will be allocated for these members also. So now using the structure variable, these values will be assigned to these members. That is 100 will be assigned to EMB code, Mr. John Smith will be assigned to EMB name, manager will be assigned to EMB designation, and 40,000 will be assigned to the EMB salary. So likewise, if we have two structure variables, right, so you can see that here we have two variables. So likewise, if for EMB2 also here the values are assigned like this, then you can see that the both the variables are accessing these arrays or these members, right? In that case, you know that if there is only one if there's two variable, then what will happen is that accessing these members will become problem. So in that case, the structure variable name needs to be different, that is EMB1, EMB2. So when the structure variable names are different, and when the structure variables are created, based on that the memory space will be allocated. So what will happen is that the values 100 will be assigned to this EMB code. Again, EMB2, suppose like 101 will be assigned to this EMB code. Now in the same member or in the same variable, two values cannot be stored, right? So now this variable will have, so when you declare this structure variable, then different memory locations will be allocated. So this variable will be assigned a different memory location, EMB2 also will be assigned different memory location. So based on that, you can make use of these members again and again, right? So you can make use of these members of the structure again and again by using different structure variables, right? So you can see that there is code reusability, so which is a huge added advantage. So based on that, even if you declare 100 employees, a real life program, or say like 100 employees, then all the 100 employees will be able to be, or they can be assigned to these members. So all the 100 employees will be able to use these members of the structure again and again, and so all of the memory locations will be different. So 100, 101, 102, 100, so like that, right? So similarly, the employee name also will be reused again and again. So that's why we declare a structure variable, right? So this is initializing within the structure, right? Now this initialization can be done, but you can see that this is already pre-written in the program itself. So when you run the program, this the data will be displayed, so user need not enter from the keyboard. But in most of the real life programs, you see that the user has to enter some input values from the keyboard, right? So in that case, the second method is mostly used, that is initialization can be done within the body of the program, right? Now another thing is that here these are the members, so, but you cannot directly initialize them, like here in EMB code, okay, equals to 100, character EMB name equals to John Smith. Now you cannot directly assign the values to the members, because if you do that, in the in that case, as you know that until and unless a structure variable is declared, no memory space will be allocated for these members. So the compiler will not recognize this at all until the structure variable is declared. And if suppose it is possible and you assign the value emp code equals to 100, then what will happen is that this variable will be able to store only one data, that is emp name will store only Mr. John Smith. After that, if you declare another structure variable, it will not be able to use these members at all, right? Now, second method is initializing the members within the body of the program. So initialization can be done by the user by entering the data using the dot operator. So this is so here we make use of the dot operator. So with it we can initialize every members of the structure variable within the body of the program, right? So the format is structure variable name dot member name. So like this is the structure variable name and this is the member name, right? So using the dot operator we can initialize all the members of the structure this way, right? So in the next video we shall see a program on structure, okay, and I shall show you how we declare the structure and how we initialize the members within the body of the program using the two methods also, right?